Well, good afternoon, everybody, and thanks, Joe, for the nice introduction. And yes, we like Patrice Bergeron and Brad Marchand in Boston, and I actually live in Washington, D.C., but Boston fan at heart. So I guess I'm the keynote here today, so was hoping to talk a little bit about what we do at the American Chemistry Council. But first of all, let me just say thank you for the invite here. Thanks to CPIA and the University of Waterloo. I've been doing this for about 8 years, and one of the distinct pleasures I have is getting to meet a lot of great, smart people, interesting people. And Joe is great to work with. I mean, I don't know if there's anybody who's more positive, and you wake up in the morning just happy. I mean, it's really great quality, and so I really enjoy working with Joe. He's a great person and brings a lot of interesting perspective to our meetings when he's in DC and on our conference calls. So we really appreciate the opportunity to kind of have the cross-border dialogue and discussion. So you're very lucky to have Joe. So let me go in a little bit of what we're going to talk about today. This is the American Chemistry Council. So the American Chemistry Council, sort of what we call the mothership, is the trade association for the chemical manufacturing industry in the United States. I'm in the plastics division. So we are a subset of that membership, and our members make plastic resin. So we have about 15 members. Many, of course, are very heavily in the polyethylene business these days. Others make polypropylene, polystyrene, and then different engineering resins that go into things like some packaging, but building and construction, and automotive and other kind of specialty markets. So just recently, if you've been following the news, we announced our circular economy goals. And I'm going to talk about these a little bit as kind of the framing and the context of what we're going to be talking about today. These were also, I think, a good example of our cross-border partnership with CPIA. A lot of discussions behind the scenes with folks at CPIA. As you know, these goals probably look very familiar as we collaborated in what our goals were going to be. So I think it was a great example of sort of that cross-border collaboration. So the two key goals I'm going to talk about today are 100% of plastics packaging is reused, recycled, or recovered by 2040, very ambitious goal. And 100% of plastics packaging is recyclable or recoverable by 2030. And that's what we're kind of calling our interim goal that's going to help us get to 2040. We received a ton of great coverage in the trade press, which is nice to see since the coverage in plastics in general these days isn't quite as friendly as you know. But really, we got a lot of good kudos in the trade press about putting these goals out there. They were announced the same week as NPE this year. And since we've announced them, we've gotten a lot of good outreach from different brand owners and other NGOs to say, hey, how can we work with you, and what can we do to partner together to achieve these goals? And it really gives us something to work for and really structure our work over the next 12 and 22 years. So here's the challenge that we have, and it's a big one. As you can see there, this is the EPA numbers. I hope the numbers in Canada are a little bit more up to date. Here I am in Canada. I'm going to kind of sort of say that the US EPA needs to move a little bit quicker, but these are actually the last national numbers that we have in 2014. They used to run about 2 years behind schedule, so this time I could be talking about the 2016 numbers, but we still only have, as the latest numbers are, 2014. So this is plastics packaging in municipal solid waste. And as you can see, about 14.8% gets mechanically recycled. Another 16.7% is mixed in the waste stream and goes to waste energy and is combusted for electricity and steam. And the other 68.5% right now goes to landfill. So nearly 70% is going to landfill. So that's really the challenge that we have over the next 22 years is getting, turning that gray all into green, yellow, or some other color that's not landfill. So I'm going to talk a little bit about recycling first, and then I'm going to kind of delve more deeply into chemical recycling since it's kind of a hot issue right now, especially for resin manufacturers. Heard about it earlier this morning from Green Blue, and so that's kind of going to be the focus of my discussion. So right now we kind of have 6 focus areas for recycling. We do a lot of technical reports and analysis. We do advocacy and outreach to governments, good value chain partnerships and sponsorships, improving collection and processing. End markets is kind of something that's obviously taken on a lot more urgency in recent years, and then national education. All these are kind of critical components of the work we do. We did put together, and I know there's been talk about sort of moving governments today. We put together something in a publication called Governing Magazine, which really sums up the way we were sort of advocating to policymakers and regulators about things that they can do or that they should encourage in their states. Sustainable materials management sort of adopt that broader view of materials and really thinking about this from a life cycle basis. Encouraging broadly supported policies, as you can imagine, when it comes to bans. And yes, in the U.S., EPR are much more controversial, and so we end up sort of having fights over policy instead of ever really moving the ball there. Let's think about some things we can do together. Embracing voluntary plastics recycling programs and tools. There's a lot of them out there. We've created a program called WRAP, which is about returning clean polyethylene film to all the retailers that collect it. Leverage programs with scale, like the Recycling Partnership, which has grown leaps and bounds over the last 3 to 4 years. And then finally, of course, treating plastics currently not collected as valuable feedstock for conversion, not as a waste product. So where does sort of kind of the recycling work and this all stand right now? Well, it's challenging, as we know. You pick up the U.S. papers, the Wall Street Journal, the New York Times, the L.A. Times, a couple weeks ago, the Boston Globe, and this is just really all in the last month, has really sort of talked about the challenges that recycling is facing, mechanical recycling. As we know, China, of course, decided to close their import market for a lot of material that comes from both the U.S. and Europe and Canada. And even Vietnam was sort of saying, wait, let's slow this down as well. So as you can see from that Statements Journal headline, it's a local paper in Oregon, it talks about some communities that are saying we're going to throw in the towel on recycling and not even collect a lot of these materials. So it's definitely a challenging environment right now, and there's one thing that gets our members' attention is sort of challenges over recycling and recovery and how that boomerangs back on the use of plastics. So there are some real challenges to mechanical recycling, so I'm going to set this up as sort of why chemical recycling is a really interesting place for us to focus right now. So the structural challenges in the current environment are really tough, right? There's enormous material variability in plastics, right? Different resins, different types, different formats, rigid, flexible, polystyrene, propylene, everything. So it's not aluminum. It's not an aluminum can, right? So much more difficult. Performance, quality, and expectations between post-consumer recycled resin and virgin resin. Very challenging, especially if you're trying to go into food-grade applications. Supply and demand of PCR, right? That's always a moving target in any sort of commodity market. Supply and demand, and those are always big challenges. We all know about the shale effect, right? What shale has meant for really the U.S. and North American chemical manufacturing industry. This is a great area to invest, and most of our members have made major investments or are planning to have announced investments in the United States and Canada. And then finally, China's ban on materials, right, has had a huge effect over the last year or so. With all that said, let's give a hand for mechanical recycling, right? Because with all the sort of the knockdowns with the green fence and China sword and the latest policy, and with low commodity prices and other challenges, it's really proven incredibly resilient. So that's great, and we need to grow mechanical recycling. Oops, slipping there a little bit. As far as we can take it, but we know that it by itself is not going to get us to the goals where we want to get to in 2040. So this is kind of how we view plastics in a circular economy. This number of 3.4% of energy, so that means natural gas and oil. So when you think about it, 97% of oil or natural gas that comes out of the ground actually goes into other uses, transportation, other chemicals, power, and other things. Only 3.4%, when it gets to 3.5, I'll round up to 4% for the purpose of this diagram, but only about 3% right now actually goes into plastics production. And so plastic pellets are made. That's what our members do. They're sent to different fabricators, right, that make them all into all different widgets that have a lot of use. The consumer uses them, hopefully reuses the plastics as well. They get collected post-use, right, and that's an all-important step in the recovery. We want to mechanically recycle everything we can, right, get back to that fabrication stage. And we've kind of added in, this is new, this real chemical recycling stage here, which really talks about, okay, let's try to get back to either some sort of basic monomers or feedstocks or some sort of energy product that can get returned back to the energy stream in which it was borrowed from in the first place. So this is really the vision that we're trying to execute on now. So how are we going to get, first of all, to our interim goal of 2030, right, which is 100% of plastics are recyclable or recoverable? So kind of 4 different key buckets there. And this isn't just the extent of what we're trying to do, but in the interest of time today, I didn't want to go through everything. But for 2030, we need to grow some existing programs, right? I talked about the Recycling Partnership and RAP. So let's grow those, continue to grow, so that we can collect more plastics, more types of plastics. We need to think about advanced sortation, right? We have a project called Materials Recovery for the Future that's looking at how flexible packaging can make it through a MRF and not end up in the paper bale, but end up potentially in a flex bale. And then hopefully some end markets develop for those products. We need new innovation. That's what that light bulb is supposed to be there. We need to think about ways we collect stuff that isn't being collected now. One of the real novel approaches that's been great, and we've seen a lot of great uptake in recent years in places like Omaha and Boise and Cobb County, Georgia, is the Hefty Energy Bag program, right? Collecting these non-recycled plastics or harder recycled plastics curbside. They ride along with the recycling. They're pulled out at the MRF and then converted to some sort of either a transportation fuel or some other product. ACC is going to continue to sort of market and outreach for both Hefty Energy Bag programs as well as other types of collection programs that are very similar to Hefty Energy Bag. And then we also need to think about what are the new innovations that are going to come down the road on sortation and collection. Really critical that we keep innovating, especially as the waste stream gets more complicated. So let's go to the big goal, achieving the 2040 goal. We've kind of established, or we've bucketed this into 6 kind of key things that we need to do. Number 1, develop new circular markets. 2, expand awareness that post-use plastics are resources, and that's a real cultural change. In the United States right now, there's over 90% access for collection of things like PET bottles and high-density polyethylene bottles, especially high-density polyethylene, right? That's your milk containers, that's your household cleaners, it's your bleach, it's your detergent. A lot of people, there's over 90% access, and yet the recycling rate for those is just hovering around 30% for many years now. So even with the access, we're still not getting what we should out of that stream. So that's a challenge. It's a real cultural challenge, hopefully, where people attach value to those. Expanding access, especially to rural and suburban or ex-urban areas. That's a big challenge in Canada, of course, as well, too. Less densely populated, both here in the United States compared to places like Europe. Developing new technologies for collecting, sorting, recycling, recovering. Expanding the types of plastics collected and repurposed. Critical. And finally, design, the all-important design. Okay, so I was talking about our 2040 our goals, and what I really want to focus on today is this number 1 here, which is developing new circular markets, including energy, chemical, and resin markets. To me, I think this is really the underpinning of sort of the system, because as we've seen, with markets being very soft right now, that we can do the best job on collection, we can do the best job on sortation, we can do great advocacy, and governments can be supportive. But if there's no demand pull, no markets for the material, once it's collected, once it's sorted, upgraded, whatever, then we're going to have trouble sort of maintaining a real circular system. So the folks familiar with the Closed Loop Fund, they are about 8-10 brand owners with Walmart came together and committed toward about $100 million to invest in new recycling technologies. I think they invested in Green Mantra up here. Oop. That better? Okay. So Rob Kaplan, one of the leaders of that group, wrote a really insightful article back in, I think it was November or so, talking about solving the recycled plastics puzzle. And really one of the key quotes is, what if virgin plastic companies were also major purchasers of recycled plastics for use in the resins they sell? This was in GreenBiz, so I would suggest kind of picking up, because I think he was really hitting on a lot of key themes about what we need to see to go forward in this circular economy. And we have seen these developments start to happen, right? And here's kind of 5 examples. There are more of different deals that have happened. So in plastics news, talking about BP, everybody knows BP, will help. They have an offtake agreement for diesel and naphtha with RES Polyflow, trying to open their first commercial plant in Indiana. The next one, they don't name the companies, but why a partnership formed to dissolve EPS for recycling. That's a partnership between Total Petrochemicals and Polystyrene. Agilix has an offtake agreement with, this one says America Styrenics, but also with Styrolution. So there's, again, two sort of virgin resin manufacturers that have signed deals for recycled polystyrene, chemically recycled polystyrene. So that's another example. Unilever has joined a partnership to turn PET waste into virgin-grade material. That's with Indorama, right? Another virgin producer. And then, as we know, in Europe, Suez and LyondellBasell, Suez is kind of like the waste management of Europe, they're forming a plastics recycling joint venture. So you are really starting to see, number one, these offtake agreements, but also sort of a little bit of vertical integration between virgin and recycling. So I think this is something that keep an eye out for. To help sort of move this forward, several years ago, pyrolysis companies led by one of the key drivers of this was Agilix, saying, look, we want to have a group that sort of differentiates ourselves from the different technologies and advocates on what we're trying to do. And so what we did was at ACC formed what's called the Plastics to Fuel and Petrochemistry Alliance. So there's 5 pyrolysis company members right now. America Styrenics is also a member, and Tetra Tech is actually a member. So we're trying to continue to grow this group, but really it's advocating directly on pyrolysis and sort of the conversion of non-recycled plastics to transportation fuels, chemical feedstocks, monomers, and other products. Really, I think pretty unique across the globe, actually, is I don't know if there is another group that's sort of really taking this on solely as an issue. So some of the work that this group does to help sort of advance this, and I'll kind of tie this all together in what we're doing at the States, we commissioned a study on emissions, right? Because everybody always asks, it's the first question, what are the emissions of these facilities? So we worked with a company called Good Company that went and gathered data from 6 companies and also looked at permitting information that's all public. It basically said, look, what they're permitted for is way below the EPA threshold for what's called hazardous air pollutants. And then if you look sort of a criteria air pollutant, by criteria air pollutant to things like universities and hospitals and food manufacturing and other types of industry, the things that people want in their communities, again, these technologies way below that from a permitting standpoint. And also the all-important question around dioxin, not an issue or concern. So really interesting study, and we use this to sort of communicate with policymakers. We also got, a couple of years ago, a very interesting U.S. government validation of plastics to fuel as a key pathway. So we worked with Argonne National Laboratory. There's a bunch of national labs in the U.S. that are part of the U.S. Department of Energy. Argonne is based in Illinois, and they maintain what's called the GREET model. The GREET stands for Greenhouse Gases, Energy, and Emissions in Transportation model. And really, it's how you make kind of an apples-to-apples comparison of over 100 different fuel pathways. So be everything from your conventional oil to gasoline or diesel, to sugarcane ethanol, your other sort, switchgrass ethanol, everything from landfill gas to a compressed natural gas for use in trucks. So they really kind of keep these, a whole inventory of the emissions, energy, and water from those, and that way people can model the sort of life cycle outcomes, and also the US EPA uses it for administering the renewable fuel standard, and then some states do as well. So compared to ultra-low sulfur diesel that comes from conventionally crude sources, they found that non-recycled plastics to ultra-low sulfur diesel would reduce greenhouse gas emissions by up to 14%, water consumption by up to 58%, of course very important, especially in areas where water is a precious commodity for agriculture and other things, and then finally, reducing traditional energy use by a whopping 96%. So really, some really good findings that have kind of, number one, kind of gave great validation to the technology, but also something that's very interesting to policymakers. So wrap that all up, where are we trying to go? And I think somebody hit on it this morning when they mentioned in Ontario, a process like Agilix wouldn't even count as diversion. And it's actually the same thing in a lot of the different states around the country. And they would take these processes and regulate them as sort of regular waste disposal and not as light industrial manufacturing. And the challenge with that is it's a challenge for investment, siting, permitting, community opposition potentially. So so our goal is to try to make sure that states regulate these technologies and their feedstocks as any other manufacturer would. And so we put together a whole FAQ about why these technologies are very similar to manufacturing and, again, not waste disposal. And it's really also, we need to be thinking about how we communicate and talk about these technologies, because we really are managing materials, not processing waste. So we want to move these from a disposal bucket in certain states over to manufacturing. So we have had some good success at that. Last year we passed a law, kind of the first of its kind in the US down in Florida. This year we passed laws, and the law passed in Florida unanimously. In Georgia and Wisconsin, we had laws passed this year unanimously in Wisconsin. We lost 2 votes in the Senate in Georgia, but it passed the House unanimously, so really overwhelmingly. We actually got through the Illinois House and through a Senate committee in Illinois this year, but unfortunately we ran out of time. It's still there. Michigan, we're working on things. Massachusetts, we're working on some legislation. Maryland is a state that a couple years ago had passed legislation to reform its recycling laws with sort of an eye towards pyrolysis as well. So, and we're looking at doing some things in Ohio and Kentucky as well, and kind of another round of states. But this message has really resonated in the states, and I think it's going to be critical to sort of create the conditions for these technologies to be able to, number one, get a permit and deploy in these states, and then hopefully that helps with offtake and other opportunities to follow. I did want to mention real quick on gasification. An interesting technology, of course, that we're following as well. One of the things that the American Chemistry Council doesn't do is sort of advocate for any individual company, and really for any individual technology, right? We kind of have an agnostic approach of, look, we want to promote engineered fuels, we want to promote gasification, pyrolysis, and other technologies. The important thing is, let them fight it out in the private market. But what we'll do is hopefully create the conditions for all of these to have an opportunity for growth. So one of the great projects we did, and this again had a real cross-border flavor to it, was we partnered with CPIA and the Plastics Industry Association in the US, and we partnered with the City of Edmonton and Enerchem, and also had the work done by Dr. Castaldi at CCNY to look at what would happen if you took a overwhelmingly biomass feedstock at, let's say, a technology like Enerchem, and added plastics to it. And what we found was increasing the post-use plastics, number one, and not surprisingly, made the process more energy efficient, yielded more useful chemical, and then also yielded sort of, or yield is probably not the right word, but resulted in less ash or waste that had to go to landfill. So overall, great results when you increase the carbon and hydrogen dense plastics to a biomass feedstock. So we really can try to connect the dots between the great job that plastics do upstream with preventing food waste, less emissions and energy used in the transportation phase, manufacturing phase, and then also their benefits and use, post-use, to making new fuels and chemicals. You can find the study, and we did a little video on it at chemical-recycling.com. So a lot of good information there. But really, I think the interesting thing was, or the great thing was the partnership with CPIA and with Edmonton. And they just have a fabulous system if folks have been up to the City of Edmonton to see it. And then quickly, I did want to talk about sort of plastics to fuel and as a pathway to monomers. One of our members from Chevron Phillips wrote an opinion piece for Plastics Recycling Update and Resource Recycling Magazine to talk about chemical recycling and to talk about the different products coming from it and how it is a potential real pathway for producing the types of things that the bigger energy, chemical, and resin companies can potentially buy someday. So really connecting sort of the plastics to fuel pathway to what we hope to see is more chemical recycling back into monomers and other feedstocks for new plastics. And let me close with just sort of talking about this recovery bridge and the opportunities, because again, relating back to our vision for how we're going to get to this 2040 goal, we really see this as an area that's going to have to develop for us to get there. But there's a ton of interest. The brand owners are very interested right now. They're trying to think about, okay, what are alternative ways we can get recycled content into our packaging and products. The Closed Loop Fund, I mentioned them before, that are investing in these technologies are very interested. And of course, the Ellen MacArthur Foundation spends a lot of time talking about these technologies as well. There's research being done by governments, by universities in the private sector. So one is an institute in the US, again at the Department of Energy, called Remade, looking at these technologies. And then we do know that existing technologies, pyrolysis, gasification, solvents and things like that, can and are doing some of this chemical recycling work now. What are the challenges? Scale, of course. You know, this is an industry at its beginning. The existing ecosystem, don't know if Brian talked about it, but really one of the challenges is we do have a system right now that's kind of set up as that linear approach, where waste is collected and going to be a little bit of recycling and then it goes to landfill. So how do we sort of make those interventions and kind of change this entrenched existing system we have now that's really going to support kind of a new paradigm of material recovery? Producing the right product at the right price, of course. You might be able to produce a great crude oil or naphtha or something, but if it's not close to the offtake of the markets, it's a little bit challenging. So, similar to anything, you got to have a customer right there. The expectations on the chemistry, I think this is a big one. We all know, I think most folks in this room maybe have an engineering background, and folks know that when an oil company takes a barrel of oil, they don't produce 42 gallons of gasoline out of it, right? There are chemistries that, in nature that prevents that. So they usually produce about 20, 21 gallons of gasoline, and then kerosene, and they get some naphtha, and they might get, they're left with petroleum coke. And so there's different types of refining that go on in different products that are produced. In a lot of ways, it's very similar with mixed plastics right now, right? We can't just sort of wave the magic wand and voila, with mixed plastics, come up with ethylene monomer that's perfectly circular. So we really have to, I think, understand that there are chemistries and limitations there as well, but we need to sort of try to push those to their envelope and not sort of let perfect be the enemy of good, so to say. So I think that's going to be critical, because I think we need to make sure that expectations are in check. Then finally, I don't think the technology is still understood well enough, and we need to do a better job of education to keep moving forward and how this relates to a kind of a truly circular economy. So that's my sort of view on things from kind of the American Chemistry Council's perspective and how we see, and again, this was just one of 6 elements of how we think we're going to reach this 2040 goal, and just markets are really critical. So again, thank you for your time today. Thank you, Joe and Fergal and Carol and everybody else. Appreciated the opportunity to be up here, and happy to take some questions. And thanks to the technology team, Jessica and others, for saving me from a lot of embarrassment. So by getting the laptop up here quick, that was great.
Craig, could you maybe share a little bit with us in terms of the number of conversion facilities in the United States, what you might have cited, what's upcoming, some advancements in that area?
Yeah, and that's where, that's a good question, is this technology is still certainly in the early stages. From a commercial standpoint, a lot of the companies have sort of demonstration or their first commercial facilities. Brian talked about Agilix's up in Portland, or just south of Portland. Vadix has a commercial scale facility outside, or in Akron, Ohio. Renewigy has a facility in Salt Lake, and I believe they're doing their first commercial scale facility up in Nova Scotia. Nexus Fuels is a company that has a facility in Atlanta, Georgia. Polyflow, as I mentioned, is looking to do their first commercial scale in Indiana. And a company called Fulcrum, I didn't mention them today, has gotten a lot of press lately. They're building sort of a gasification facility in Nevada that's going to be, and they have an offtake agreement from United and Cathay Pacific for jet fuel. So kind of an interesting MSW to jet fuel. So we still are kind of at that infancy. And so I think that's, but I do think sort of with the moment that we're at right now, I mean, I think there's just been a real turning point sort of in the way the public is viewing plastics, the urgency of the energy and the chemical and the plastics manufacturers. I think you're going to see sort of a quicker pace of development and interest down the road. At least I hope.
Thank you for the nice overview.
Thanks.
My name is Manju Misra and I am from the University of Guelph, Canada. So my question is with regards to the conversion of non-recycled plastic to the diesel. So are you considering the thermoset plastics also and any kind of plastics, and what is the status? And you mentioned that government is validating that one. Could you please little bit comment on that?
Sure. On thermosets, it's a good question. I don't really know if there's, when you're trying to start a new technology, right, you start with sort of the lower hanging fruit. So I know that most of the companies that are in sort of this pyrolysis business and trying to make diesel and other sort of useful petroleum products are really looking at the polyethylene, polypropylene, polystyrene feedstocks. So thermosets, I think, is a tough sort of, probably a second level. And truth be told, I would ask sort of some of the companies about whether they've tested those feedstocks. And Agilix might have. They've tested a lot of different materials over the years. The second part of your question, I think, was on U.S. government validation. So in the U.S., there isn't a tremendous amount of sort of regulation that really fully impacts these technologies. There are places where we've tried to, well, let me step back by saying, so the U.S. has something called the Resource Conservation and Recovery Act. And at the end of the day, when it comes down to it, really that's sort of a great example of federalism, because it really empowers the states to do most of the regulatory work around recycling and recovery. And there's certain things around, we have a renewable fuel standard, but anything that doesn't come from a biomass feedstock is locked out. There are tax incentives, but with running a big deficit, it's tough to, there was a big tax cut recently, and a lot of spending, so those tax incentives for alternative fuels are kind of under attack. So a lot of the direction really doesn't come from the, I don't think a lot of the companies are sort of hitching their wagon or hoping that the federal government is going to come along at any time and really promote this stuff, but really can play an enabling role on validating the environmental benefits of this technology and stuff that then we can take to state lawmakers to hopefully improve the situation in the states. Hopefully that answers your question.
Thanks a lot, Craig, for the presentation. Just a quick question on recycled content, more on the policy side in the US, California with their recycling mandate for rigid plastic. I think there's a 25% law. What are your thoughts on that type of approach, and how has it worked out in California?
Yeah, do you know Steve Alexander from the Association of Plastic Recyclers? So if he was up here, he would be pretty upset, because he would say, one thing that they've been asking for 20-something years is for them to just enforce that law. And I think that's part of what we've been saying in a lot of different states is, before we start creating any new mandates on things, let's enforce the existing mandates that are already out there. I think Steve likes to say that the RPPC law in California has had maybe 1 or 2 violators or something over 20-something years, so it really hasn't been all that effective. Recycled content mandates is one of those interesting gray areas right now. I won't totally dismiss them, but I'm not going to sit here and totally endorse them either, because I think as we're looking at, okay, how do we achieve this 2040 goal of keeping all plastic packaging out of landfill and into recycling and recovery, a lot more options are kind of on the table now than they might have been a couple of years ago. But I think our basic thing would be, let's first enforce the laws on the books and do it right before we start putting in a bunch of new mandates when we can't even get the existing mandates right. And similar, just another example of that is, Connecticut was looking at a new EPR law a couple years ago, and one of the things that we looked at was, what do they do right now? They have a deposit legislation there, and it generates some $30 million a year or so. And back in, I think, 2008, 2009, the state legislature had said, hey, let's take this money, because it's a decent pot of money, and let's shift it away from recycling and just put it into the general fund where it can be spent on anything. And so one of the things we also said to the state of Connecticut was, wait a second, before you go and create this new system and sort of, and you're a smaller state and kind of create a lot of upheaval, why not first look at the existing streams of money that you have? I mean, there's $28, $30 million a year that you used to capture that you're not. So why don't go back and get that first and use that to build up recycling before sort of creating a new approach. So I think that's a key thing. Before we look to government to sort of save us, let's make sure that they're already, doing a good job with existing regs and laws.
I had a question kind of built off of the post-consumer recycled content. And the challenge is, I guess a couple times with brand owners, particularly in food and beverage, there's fear of direct food contact applications. Also, PCR content traditionally has been at a higher price. How do we get so that brand owners will, and we saw yesterday in the presentation that P&G is an example where they have set goals specifically to put in PCR content, but how do we get more brand owners that are willing to do that to help drive that market? Is it that things like the National Sword is now providing an opportunity for low-cost access to PCR, and so that could spur, or are we going to have to wait for chemical recycling to come on to provide that kickstart eventually?
I think it's going to be a little bit of both, from both chemical recycling and sort of improving the existing mechanical recycling stream. I'm glad you brought up, I wasn't here yesterday, but brought up Steve Secra and PureCycle. There's a great example of a company that said, look, we are in we're not in the polypropylene business, but we use a lot of polypropylene. Our customers want us to use more recycled content. We're not thrilled with what's out there right now, so we're going to go and kind of develop our own thing. So I think that's a great solution or opportunity potentially. Some of the examples that I showed here, LyondellBasell partnering with Suez, Total, and Polystyrene. Those are examples of the virgin industry sort of looking to partner to sort of say, okay, how can we produce much higher grades of recycled content resin? And then, back to chemical recycling. And that's what Unilever is trying to do with Indorama, right? And they get to their recycled content goals by turning this back into a monomer and then making basically what's virgin PET again. Same thing with America's Styrenics and Agilix. They can get that back to a monomer. You can sell that as a recycled, essentially a recycled content resin that is essentially a virgin resin in the way it acts. So I think it's going to be a lot of different innovation. I think, again, what's kind of different now is I do think the private industry is really thinking about what their customers want, and that's what's motivating the P&Gs and the Totals and the Amstais and the Lyondells, so they can sort of provide to the brand owner that recycled content that they want to bring that their customers are demanding of them.
Well, that was
Kicking me off?
fabulous. Yeah, I'm going to take the big hook. Really enjoyed your presentation.
No hockey talk or anything?
Yeah, well, look who won the Stanley Cup.
Yeah.
Anyways, first of all, fabulous insight. You provide great leadership, I know, on the PERT committee and recycling. Keep it up. We really enjoy it. And you do help us here in Canada with all your good research. And hopefully we can share what we learn here. So I'd like everyone to give Craig a round of applause, and please take this as our appreciation of you making the trip up here. Thanks a lot, Craig.